welcome everyone and thank you for taking the time today. The goal of this presentation is to give a very high-level overview of the SBOM work that's been happening now for a few years across a range of communities. And one of the things we'll try to capture here is that SBOM isn't specific to any one community. We all care about software and the security of it and supply chain. But we need to understand how it's going to impact our own corners of the world separately. What we wanted to do today was bring together some folks from across the energy community. And so today we're going to give a high-level overview of what this SBOM thing is all about, flag some of the work that's already been done, and really focus on the basics and saying if you want to start this, there's a lot of things that we can do, but we're going to really focus on what's going to get started. Then we're going to hear from some friends with a lot of experience in the energy sector on the value of this and how this can help the energy sector. Tom Alwich, who some of you know from his blog and his long career in the energy sector. And we also have some friends from INL, Ginger, and Andy, who've been around for a while. I want to thank our friends at the Department of Energy who've been a supporter of this for a while. Sherry Caddy, in particular, the CSER program, is joining us today. And then we're going to very briefly from this proof of concept idea. And this is really what we're going to be working towards as a community, is to say, hey, how do we try this? How do we experiment and find out what works and what doesn't? What can we build on that other people have learned and figure out what needs to work? And then lastly, we'll talk about the next steps for this community. But the core takeaway is that SBOM is an invaluable tool for managing the security and supply chain risk in software, and that there's a real opportunity for the community to safely experiment, to say, hey, what works for us? What do we need? What are the tools? What's the organizational structure? What incentives do we need? There's a lot of stuff that we can talk about, and we will be talking about over the coming weeks. So I'm going to start with a few brief motivating examples. Many of you have heard about Amnesia 33 vulnerabilities. We find new vulnerabilities every few months that widely affect a lot of software and embedded components that are really deployed everywhere in our ecosystem, especially in the energy world. And for me, the crazy thing is how few organizations on the entire planet can quickly and easily answer a very simple question. Am I affected by this? Whether you make software, or whether you ship software with your products, or whether you're just running, embedded systems that use software, it's a very important question. Am I potentially affected? And it's really surprising that very few organizations can do this, especially for things that are either uncommon manufacturers or lower down in the supply chain. Here's another example. This is a guy named Shlomi I've gotten to know. He's the head of a company called JSoft. They found the Ripple 20 vulnerability. And one of the things that they had to do when they found this vulnerability is say, okay, before we go public, they wanted to give their talk at Black Hat last summer. And before they did that, they said, well, we need to talk to the vendors that are affected. But they didn't know how to figure this out. The Trek IP library is a very low-level library that's used in other things, that's used in other things, that's used in other things. And so no one was publicly saying, hey, we're using this, or even privately saying we're using this. And so what he and his team had to do was they had to go on LinkedIn and use OSINT to say, all right, well, this person was bragging about having experience in the Trek IP stack. We'll find out who their employer was when they were working there. Okay, probably this product family, and now we can do some disclosure. The third example is just you don't necessarily know what you have, right? A lot of the products that we have are sold and resold and integrated. Here's just a simple example that some folks at NTT Labs have done, where they say, hey, all of these cameras use the same underlying software, but they're sold under different names, and they're integrated into other much larger and complex security systems, but they're all under different brand names. The kick is they all have the same underlying software and firmware. And by the way, it's all very vulnerable. And there are attacks in the wild against this type of tool. And so what we need to do is have more transparency in the supply chain for that. Now, transparency isn't a new idea. Right? We see this in a lot of other areas. If you decide that you want to go and get yourself a non-biodegradable snack, you get yourself a Twinkie, and you look at the list of ingredients. And you say, hey, it turns out this has tallow. Well, first I need to know what tallow is, find out that it's beef fat, and maybe that's fine, that a Twinkie is not vegetarian. But we all know someone for whom that would be an issue. They've got a food restriction, a sensitivity, and the goal here is to make that data available in an accessible format so they can make the right risk decision for themselves. And that's really the vision here. But we see transparency in other marketplaces. Some of you are familiar with the chemical industry, which has safety data sheets. It's an international standard that says, hey, you get a pallet of 50-gallon drums on your plant, and one of them upends and washes all over Bob. What do we do about Bob? Well, there's a data sheet that tells you, right? That's the transparency approach. And those of you who come from the hardware world know that we have the idea of a bill of materials. If you build something before you can launch at the factory, you need to say, I need this many widgets and this many widgets. And the power of naming things can help drive further innovation, right? So think about how much of the way we think about vulnerabilities today depends on the CVE infrastructure, for example. That in turn allows security tools to help people better understand their risk. And that's our vision here, is to say, how do we empower people to make better decisions and think about risk more promptly? So we're talking today about software and the software supply chain. Here's an example that's come from some of the folks in the NTIA group that have been focusing a lot on the healthcare side to show, hey, the stuff we're building starts with small parts. And in the software world, right, we start with very small units of software and, you know, small open source libraries, primitives, and those in turn are used in larger pieces of software, you know, crypto libraries or access control libraries. Those in turn are folded into bigger pieces of software, operating systems, for example, which in turn then get folded and used in the embedded devices. And all of those end up getting used by the operator, by the asset owner. And the vision of thinking about the software supply chain is we need to accommodate all of it. And we need visibility. So it wouldn't be a proper tech talk if we didn't have an XKCD cartoon. And so, right, here's this approach where we have this lovely modern infrastructure, but a lot of it is built on relatively small things. And many of you out there are spending time saying, what's in here? What we need to do is have everyone starting to pay attention and looking up our supply chain and saying, hey, how much of this is dependent on one small project where, you know, if the wrong person looks, you know, forgets to look both ways before they cross the street, we no longer have a maintainer. Or even worse, this is a small enough project that someone could come, an adversary could come and subvert this and actually do some damage. Having visibility is the first step to preventing that. But we're here today to talk about SBomb, right? We're not trying to solve all of the software supply chain issue. So, you know, starting point, what the heck's an SBomb? And an SBomb is just the dependency tree. We're trying to say, what are the components that you're using? What are their components? How do we have visibility on this? Modern software is not hewn out of alabaster marble by, you know, tonsured monks on Greek islands. Modern software is built out of existing components. And as hardware gets cheaper, those of you who've been following the history of the industry, as hardware gets cheaper, we're having more and more general purpose hardware and more general purpose software running on top of that in our embedded system. Obviously, there's going to be lean efficiencies, especially in the energy sector, but we're seeing more and more general purpose software, and that's the challenge. And so a software bill of materials is this list of ingredients or this nested inventory. You know, A contains B, B in turn contains C. The definition that the community has come up with is it's a formal record containing the details and supply chain relationships of the various components used in building software. Some people look at SBomb and say, we want all the data. We want to have as much possible information as possible. But what the community has done is they've adopted a crawl, walk, run approach to say, let's start with the basics of what we have. So here's our toy example of an SBomb. We have our Acme application, which has exactly two dependencies, Bingo Buffer and Bob's browser. And Bob's browser in turn depends on Carol's compression engine. Right? For each of these components, there is a minimum amount of information we need to sufficiently uniquely identify it. So what's the component? What's the supplier? What's the component name? What's the version so that we know if it's up to date or not? And then what's the hash so that you and I both know that we're talking about the same version and you feel confident that I haven't downloaded a backdoored version that from some website that we're talking about the same version. The other thing I want to flag here is that an SBOM does not presume to be the complete graph. You can ask for one if you want, but the key aspect here is that we try to make the known unknowns explicit. So in this case, we know an Acme application has exactly 2 dependencies, bingo, buffer, Bob's Razor. We know that Carol's compression engine has no further dependencies. We don't know what's in bingo buffer. And that's okay because we all are on the same page. And so now, if you're getting that piece of software, you can say, well, that's fine. I have the top level dependencies. That's the priority. Or you can say, I'm going to hire a pen tester, or you can have a contractual discussion. But the important thing is that it's visible. So this is such a good idea. Why aren't we doing this today? Because I think it's important to acknowledge some of the history. First is there are some real concerns about licensing and open source restrictions. A couple years ago, that was a much bigger deal. I think today that's something that most risk officers understand, regardless of sector. And there are some commercial off-the-shelf tools that will help you understand this issue. It's also a bit of a chicken and egg problem, right? No one's asking for it, so no one's providing it. No one's providing it, so no one's asking for it. And I don't want to overstate how simple it is. If you're writing software and you've got a good modern process, actually getting this data should be pretty natural. It should be pretty straightforward. But if we want this to scale across the community, it needs to be machine readable for automation. And that means having a shared vision and building in around some existing standards and some existing approaches that we have and that the community has developed. And the final thing is it's complex. Right? This isn't just a technical problem. It's not just an operational problem. It's not just a business problem. The sticky issues, the wicked problems involve a little bit of everything. And that's what we've tried to do as a community, is bring folks together. A couple more points. First, I don't want to leave the impression that anyone thinks that SBOM is going to solve all of our problems. It won't. In fact, you could argue that SBOM by itself may not solve any of our problems. But with the power of software transparency, you can definitely support all of the things that we know we're going to need to do. And Tom and Ginger and Andy are going to talk a little more about this, but I just want to flag that if we sort of look at the life cycle here, whether you're making software or buying software or operating software, SBOM can support that. Whether it's having an SDLC and supporting allow lists or deny lists, or thinking about supply chain, or thinking about third-party risk management, or thinking about vulnerability management, SBOM is absolutely essential to move forward in this progress. So very briefly, what has NTIA been doing around this is we've been trying to act as the nexus for this discussion. Been tackling this as an entire supply chain issue, right? This isn't just an open source issue. It's not just a commercial software issue. It's not just an embedded systems issue. And perhaps most importantly, this discussion has to involve the customers, the asset owners who are going to be using the software to make sure that they have some visibility into it. So we've got to cover the entire supply chain. And similarly, it's got to be cross-sector. What we don't want to do, and why the Department of Commerce has been engaging this, is we want to avoid having sector-specific solutions where everything that DoD buys does it one way and everything that the healthcare world buys does it another way. Well, that's terrible because we all use the same software, especially as we move up the supply chain. And so what NTIA has done is we brought together software and security experts from across these sectors to say, what's this shared vision that we can have to establish it? Some caveats, what we're not doing. We're not building out regulation. NTIA is not a regulator. This is not about source code disclosure. We know it's a hot button issue. And this is not a formal standards development process. In fact, we're talking about using existing standards that we already have so that we don't have to invent anything new, so we can have faster adoption. And of course, the final caveat I keep coming back to is we're not trying to solve all supply chain assurance issues. We're trying to create this layer of transparency that can in turn help more of your solutions. And the last thing we're going to talk about today is that we want to go beyond just talking. Right, it's one thing to write some papers. There's some lovely documents at ntia.gov/SBomb, which we'll point you to at the end of this presentation. But our vision here is to say, let's focus, let's move past the descriptive stage and actually say, what can we build today? And what are the obstacles to getting to this world that we want? So with that, I will shut up and stop talking about this, and because you really want to hear from some actual experts in this. So we're going to turn things over to Tom Ulrich to talk a little bit about some of the energy use cases, and then we'll go to our friends at Idaho National Labs to talk a little bit about how they're seeing it, and then we'll close out with some discussions from folks from other sectors that they've been saying, well, we're going to try to of what they've done to experiment with this as well. And in the meantime, if you have any questions that you want to queue up for the Q&A at the end of this session, please use the chat window for this Teams meeting. Thanks so much. Tom?
Thanks, Alan. I hope everyone can see my slides now. My name's Tom Ulrich. I'm an independent consultant to the electric power industry, and I write a blog that on cybersecurity in the power industry, which gets a lot of attention, which you can find by going to the innovative title of Tom Ulrich's blog. And I want to make 2 points about the, to point out, I've been working with the Software Transparency Initiative since last August, attending, a lot of their meetings. And I've also volunteered with Alan to help organize the energy sector POC, which is why I'm here today. So I want to discuss 2 topics. One is use cases for SBOMs in energy. That is, what can they actually be used for? And then we'll get to the other one after that. So there are many use cases for SBOMs. There are use cases for software suppliers as well as for organizations that use software. And there's an excellent document out on the NTIA website, roles and benefits for SBOM across the supply chain. And I have the link there. I recommend you read that. It really is a very good document. And it goes much beyond what I'm saying today, of course. And I want to focus on what I consider the 3 most important use cases for SBOMs for power industry organizations, or really for any organization. However, when the proof of concept starts, it will be up to the participants to decide which use cases they wish to focus on in the POC. So the most important by far of these use cases is vulnerability management. The average software product contains many components, both proprietary and open source. In fact, most estimates are that the average software product contains at least 100 components, and maybe sometimes many more than that, in the thousands. So the problem is each of those components can have vulnerabilities, but you don't know about those vulnerabilities unless you know what components are in there. So to manage vulnerabilities, you normally enter the name of a software package in the NVD, National Vulnerability Database, and then you get a list of vulnerabilities that, if any, that apply to that product. And you can also simply scan the software with Nessus or a similar product. But few energy organizations try to manage vulnerabilities in components of a software product because there's no way they can do that without an SBOM. So they have no idea what the product components are. And the NVD, unfortunately, doesn't have an idea what components are in software either. So with SBOMs, your organization can track and mitigate vulnerabilities in components of software you own, as well as vulnerabilities in the first-party code itself. It is the code that was actually written by the supplier that you bought it from. The second use case is procurement. When you're procuring software, you should learn about vulnerabilities found in the products you're considering. You're probably doing that now, but again, you're just looking at the CVEs that apply to the product. You're probably missing, unless you have an SBOM, and very few people do now, you're missing the CVEs that apply to the components of that product. So if you know about open vulnerabilities and components, of course, you can require in your purchase contract that they be patched or otherwise mitigated before the purchase is complete. And more generally, you can have terms in the contract for how the supplier will deal with SBOMs. Well, I'm sorry, with component vulnerabilities. Specifically, you want to make sure they patch them within a certain amount of time, just like they patch their own vulnerabilities within a certain amount of time. And there are a number of other policies you can ask for as well. But again, the most important thing is that they provide an SBOM, and you do want to get them to update the SBOM whenever the components change, because that's that requires a new SBOM. And the third use case is what I call the Ripple 20 syndrome. And I have here, how many of you have to respond to the Ripple 20 vulnerabilities? So you can raise your hand, but unfortunately I can't see you. But I know a lot of you did. And those were serious vulnerabilities in a component, actually an IP stack from Trek, a company in Cincinnati. They're estimated to affect hundreds of millions of products worldwide. So if you had had a list of every software or hardware product on your network that was affected by Ripple 20, your job would have been much easier when this came out. But of course, you need SBOMs in order to have that list. So now I can't promise that SBOMs will ever give you a list of every product that contains a particular component. In fact, I can guarantee that that will never happen, 100%. But I can promise you'll be much better off with SBOMs in general than without them. And more specifically, SBOMs aren't an all or nothing proposition where you either have them for everything or, and if you're missing anything, then you might as well not have them at all. It's not that at all. Every SBOM you get helps you. And even if it's just a partial SBOM, it helps you. It doesn't have all the components, but it has some of them. You at least know about those components and you can look for vulnerabilities in them, et cetera. You can't do anything without having some sort of list. So the second general point I want to make is that we're not talking about regulations here. Alan, I'm expanding on what Alan said. In a highly regulated industry like energy, you might think the proof of concept will produce standards, guidelines, best practices. That was honestly what I thought would happen in a proof of concept when I first got involved with this. But that's not what NTIA does. They try to promote use of important new technologies, and emphasis on the word new, by the private sector. You can't regulate a new technology into existence. Maybe 15 or 20 years from now, SBOMs will be ubiquitous, and then you'll have to start worrying about regulation, but they're unfortunately far from ubiquitous at the current time. So what's needed to get going is informal agreement by a critical mass of software suppliers and users on how SBOMs will be produced and consumed. And the best way to do this is by industry. There's the healthcare industry, which you'll be hearing from very shortly, started work in 2018 on their first proof of concept, and they're now on about their fourth iteration. And they're still going, and they're expanding what they cover in each iteration. Autos, you'll also be hearing about, is going to start very soon. And we hope energy will start soon as well. This is an example of what I mean by, getting a new concept going without regulation. One of NTIA's most important successes was DNS. While they didn't develop the concept, they established the structure for administering DNS. And in the 1990s, NTIA turned this job over to the Internet Assigned Numbers Authority, which runs DNS today, or Internet Assigned Names Authority, I guess. But in any case, it runs DNS today with a budget of around 100 million, which, by the way, is almost as big as Alan's budget. And he says with a broad smile. Okay, nobody is required to use DNS. That's the important thing. If you have a religious objection or something and you don't want to use it, you're free to give your, everybody who wants to use your website, if you can find them, give them your 24-digit, IPv6 address, and have them type those in perfectly, and God help them if they miss one character, they got one number, they got to re-enter everything again. But if you think that's a better solution, go for it. But you get the idea. The internet as we know it today would just simply not exist, or be much smaller, probably like it was around 1992. were it not for DNS. But DNS only exists because users and producers of web content have agreed it's an efficient, effective solution. There's no regulation behind it. And we want to have the same thing be true for SBOMs. It'll come into effect, they'll be widely used based on the agreement that they're useful, not on some regulations that compel people to do something. And that's my presentation. Thank you.
Thank you so much, Tom. I really appreciate that. And I really like that that perspective, saying, hey, this is how we can use it, and this is why we're going to need it moving forward. So now wanted to turn things over to two folks that those of you who come from the ICS security space probably already know, Ginger Wright and Andy Bachman from the Department of Energy's Idaho National Labs. Ginger,
thanks,
Andy?
Alan. Yeah, thanks very much. Nice to be with all you people today. I'm dialing in from snowy Milwaukee, and glad to have an indoor job. I'm not supposed to be on the stage for this particular talk. That's going to be Ginger. You can think of me as the person that's setting the stage. I'm in all black. You can barely see me. I'm just over on the side a little bit. I first heard about SBOM through friends. Some of you will know, named Josh Corman and Bo Woods from I Am the Cavalry. And this was in the healthcare application, trying to use those same sort of cereal box. And I hadn't seen Twinkie before, but the Twinkie examples, you want to know what's in it, for better or worse. My first encounter with the impulse, or sort of the business case for SBOM in the energy sector in particular, happened shortly after I joined the Idaho National Lab as part of the DOE lab complex. We hosted what was called a Section 9 meeting, and I was sort of the MC for it. Facilitator is a better word. And all around the table, basically chief security officers from a number of the larger electric utilities in the United States. When they were asked what would they like to see, what could DOE do to help them, they said, or at least one person started and then others chimed in and said, whatever happened to a thing called the NSTB, the National SCADA Testbed? That seemed like a good program, and it was starting to shine light on some of the things that we use and depend on and try to secure. But then it went away, and we don't know why. Well, there's no real good answer to why it went away. But what it was, real briefly, was a program that allowed important pieces of electric grid equipment, most often made out of hardware, software, and firmware, as they still are today, to be sent to a national lab, most often the Idaho National Lab, where folks like Ginger and others with extreme depth in these, extreme expertise in these matters would give them a biopsy. Sometimes the probing would be fatal. Sometimes they could put Humpty Dumpty back together again. But either way, their job was to find everything they could. Now, the nature of the contract was the information only passed between, or primarily passed between, the government, as in the lab, which works for and with the government, the lab experts, and the suppliers. So the suppliers got to find out what we found out in their systems. And part of that is provenance, where, from what we could tell, things came from, and part of it is the vulnerabilities that we could detect. And there was always plenty of things in there, to be sure. When the Section 9 people a few years ago asked for a revival, or at least suggested a revival of that program, it started something in motion that, maybe because it's government or because it's technology or both, took years. But ultimately, what we have now, in a program for which Ginger, my good friend and colleague Ginger Wright, is the PM and spiritual leader, is that instead of it being a two-legged stool with information passing back and forth between the government and the suppliers, and the asset owners, the utilities, peeking over the fence to try to see what they could see, this new program is one that has a three-legged stool. In a sense, the technical part, absent SBOM, is something that we've done before, and would be able to do so much better with SBOM capabilities. It's more of a legal grand challenge trying to get the three parties with all their attorneys to agree of what's okay to share and how and when and all that stuff. So that's sort of the use case in our sector, or at least a small part of it, and the setting of the stage for what you're about to hear now from Ginger Wright. Without further ado, please take it, Ginger.
Thank you, Andy. That's a great introduction, and I appreciate that. So I get to be the portfolio manager for INL at INL CyberCore for Energy Cyber projects, and there are a number of wonderful ones, including Citrix, which is DOE's multi-lab test and evaluation program for ICS, as Andy indicated, bringing forward the legacy of the National SCADA testbed into a more modern approach. One aspect of its modernity is that instead of just performing vulnerability testing, Citrix is leveraging enumeration as a core part of what it does, understanding what's inside the industrial control systems and recording that so that we can identify places where there are common vulnerabilities caused by the use of common components and measure the impact product by product of some of that common use. So in Citrix, we're leveraging the software bill of materials as our framework for recording our insights from enumeration of products. And we do that because we foresee that by recording our results in this measurable way, we get transferability. We can tell a vendor what we've seen. We can tell any interested stakeholders what we are seeing and understand how the products come together in a way that can be consumed by external parties. It gives us a completeness and an understanding of what level of completeness we have come to, rather than, well, we found out all we could. We can get a sense of where do we have known unknowns. It provides a structure for our results that lets us, again, share them between the laboratories and external parties. Repeatability that gives us ease of analysis, comparability of results between labs, and eventually will allow us to consume enumeration products recorded in a software bill of materials format from external parties, so that the labs don't have to be the only entities having fun testing products and doing the enumeration. DOE is making a strong investment in software bill of materials and is starting to inculcate this technology in multiple research efforts, not just Citrix. So we're looking forward to this proof of concept and to understanding where the industry would like to take SBOM and where the key use cases are. Back to you, Alan.
Thank you so much, Ginger. And I love that finish, which is, hey, a lot of people are doing some amazing work in this, right? We all know the problems that we face in ICS security writ large, and especially in the energy and bulk power space. Like, we've got a lot of work to be done. And there's a lot of great initiatives that are coming around. What we want in our vision for SBOM is to help support that, right? And also make sure that what we're doing is something that really builds on the entire software community. And that's that tension. We want to make sure it builds on the entire software community, but also reflects the needs and the unique situations that we see in the people who make all of the equipment that we depend on for pretty much everything in our world, and also the people that are using that equipment. And of course, all of the third-party vendors that are supporting both of those groups. So our vision is that sort of has grown up in this SBOM community is to say, hey, you know what? Let's try it. Let's see what happens when we try to generate this data and use this data, and what lessons we can learn. And the leaders in that space have actually been from the healthcare sector. And so I want to introduce Jim Jacobson from Siemens Healthineers, who has been one of the key drivers of this for the last few years, to talk a little bit about his experience and the work that he's helped marshal in a sector that, I'll be honest, has not always been seen as the vanguard of security. So it's really amazing that they've been able to lead this. Jim?
Thanks, Alan. Sorry, I had to get off mute there. I'm attempting to share my screen here. So let me know, if you will, when you see it.
We're almost there.
There we go.
There we go.
All right. So Alan was talking about this SBOM community that's been talking about SBOMs for a few years now. When we started talking together under the NTIA umbrella, there were a number of questions that came up in terms of how exactly you would create an SBOM, what SBOM, what are the detailed structures, etc. But also present in that group was a collection of medical device manufacturers. We create the medical devices, and hospitals or healthcare delivery organizations that consume the SBOMs, potentially. But they certainly have our equipment in their hospitals, which they don't have visibility into it. So while everyone else was saying, let's define better what needs to be in an SBOM, let's go through all the nuances and the use cases, we said, let's just try it and show that it can do something. So that was the genesis of this proof of concept in the healthcare arena. What we really wanted to do was prove the value of the information that could be transmitted from one side to the other, so to speak. What we did was put this under an NDA so that the exact data we were sharing, because it wasn't sanctioned and official documentation from the manufacturer, we established trust by creating these SBOMs under NDA between the participants, the manufacturers, as well as the hospitals. And we wanted to determine the value, and the value really meant, in this case, some use cases in risk management, procurement, asset management, and vulnerability management. There were about 12 use cases all told that we were examining, but we wanted to prove that we could transmit information from one agent to another and still have that be valuable information that was never available to the consumers, so to speak. So what we did was we created this proof of concept that transmitted the SBOMs we created SBOMs, sometimes manually, sometimes using some automation, and as manufacturers, and then the hospitals would then take that information into those that was in those SBOMs and exercise those use cases. All along, we still stayed in contact with the broader community so that we could have their input into how we construct those SBOMs, and also provide the findings that we discovered while we were actually working this through, so they could then take that information and build a better picture of what the future of SBOMs would be. So at the end of this proof of concept, we proved the value. We proved that we could exercise some real life use cases in risk management, in vulnerability management, and asset management, and provide that transparency. What we also were very clear on was that there was nothing specific to healthcare in what we were accomplishing here, that it had broad applicability across all sectors and verticals. And that was the first proof of concept. Then we established a second proof of concept in last year, basically. Ran most of back last year, even while the hospitals were fighting COVID. They still were engaged and fighting the good fight in evaluating SBOMs. So we took a different approach here. We involved tooling suppliers, vendors in these activities, because that was what we expect the real world to be in the future, or even today, starting today. We took a more agile approach too. So we set up multiple iterations. Each iteration would discover and explore new aspects of SBOMs, new use cases, new content that could be provided, new ways of interacting with those SBOMs. And then we also had a series of waves in each iteration, so we could not, so we didn't just dump everything at one time on top of the hospitals, but rather gave them the information as it was available, so that we could be more agile and more iterative. We looked at formats, we looked at tooling and automation, we had greater depth of information as a focus compared to the first proof of concept, and also providing more context about the SBOM's component information than was previously available. And again, as we went through this, we worked with the broader community because SBOMs were getting more and more defined from this broad community, and we established our goals based upon input from them. So that's how we structured the proof of concept. There's a lot of details in it. I know Alan said he was going to provide the link to our first proof of concept report, as well as all the other documentation. But the key takeaways that we had were: you need to establish a trust and collaboration between the various partners that are operating in this world, because that's the key, that we're providing transparency, and that you need to establish trust by real information. And then we, as it has been mentioned, we took an incremental approach. So the crawl, walk, run approach. So we started with the very basics, and then added increasingly more complexity and nuance to the information that was being provided. We also have to acknowledge that we need to develop the ecosystem, and working with third-party providers of solutions and tooling is one essential component of being successful. And we also wanted to define playbooks so others could follow in our footsteps, so to speak, both within the healthcare industry and outside the healthcare as well, because there was nothing specific to healthcare in what we explored in these two proofs of concept. And with that, Alan, I'll turn it back to you.
Thanks so much, Jim. And I just want to echo something that Jim said, which is it really is a testament to how important this is seen from the community, both the people who make medical devices as well as the people who keep people alive with them, that this has been a priority in the middle of the world's worst public health crisis. And I should also add that Jim and his team and all of his colleagues' teams have also been very busy defending the medical devices that are keeping people alive. So this has been something that's busy time across the board. Now I want to have just a few words from Charlie Hart to sort of flag again what's happening in the automotive sector, so you can sort of see that this is something that is cross-sector. And I want to have Charlie share sort of why he thinks that community felt that this is important and what they're going to be doing moving forward.
Hi, everybody. This is Charlie Hart. I'm with Hitachi America R&D. Thanks very much, Alan, and thanks to everybody for coming today. I'm going to follow on Jim's presentation. He gave me a perfect lead-in, which was, other sectors, basically, right? So we are shamelessly copying everything that Jim and the healthcare guys have done in their industry into the automotive industry, and we're very excited about the prospects. So I'm going to just share my screen here. Can you guys see that?
Yes, we can.
Okay.
You can expand
blowing it up
if
now.
you want to make a
slideshow, if
presentation.
it actually works.
Yep.
There we go. So first of all, I need to put a small disclaimer out there. Actually, a couple. The first one is that this POC is being done under the auspices of the Auto ISAC, the information sharing cyber organization for the automotive industry. And there are a bunch of NDAs associated with that, but you do get a lot of advantages as well, some antitrust exemptions and so forth. And you also have all the right people at the table from all the right companies. So great advantage, but I can't talk too deeply about who's involved and what we're doing inside. Second is that, I work for Hitachi America, which is an umbrella organization. I know there are Hitachi people on the call. Right now I'm working with the former AMS people and some people from Japan. We have not yet gotten into the energy side. If you would like to get some more information about that, please contact me offline in my Hitachi address. Very quickly, I just want to say we feel like software hygiene and supply chain hygiene generally in the automotive industry is absolutely critical. It's also, we feel, inevitable, and it's the right thing to do, but it's also something where we think that, at least in the auto side, regulators are going to start to get involved. Best practice and standards will be involved, and we would like to lead those areas rather than being led by them, right? So we don't want, we want to self-regulate and do a good job and have whoever is in charge of administering all that say, okay, that's great, just keep doing what you're doing. There have been no regulations heretofore in the automotive industry at all regarding SBOM, and we expected some to come out with a couple of new standards that recently emerged, but those did not contain detailed SBOMs. So we've been working on this for about 18 months regardless of that, and just this week, or last week, I guess, NHTSA, the National Highway Traffic and Safety Administration, came out with their draft cybersecurity best practices for 2020, and it did include 2 sections that deal specifically with SBOMs. So we feel kind of vindicated. We're very happy that the NTSA has seen the value in this, and we feel like the auto industry is leading in cybersecurity generally, and we're very happy to be helping NHTSA with that. Okay, so that's sort of the setup. So what is this project? We have a whole bunch of industry people in Auto ISAC, obviously, from all different spectrums of the supply chain world. Automotive has a couple of things that are very interesting, I think, that are worth citing. First one is everything in automotive, if it's not regulated, is between the contractor and the supplier. Right. So if you have a contract with a consumer, then that contract dictates all of the requirements for that deal. There's not a lot of, sort of uniformity across those things. So one thing we wanted to do was to make things more uniform with respect to SBOM, because it is complicated, as Alan mentioned. The second thing that's unique is that we have a multi-tier supply chain. Now, every industry has this, but in the auto industry, it's really called out and very specific. We have OEMs with the manufacturers, tier 1s, which are deal directly with the manufacturers, tier 2s, which deal with the tier 1s, and then a series of tiers that can go down about as infinitely as you want. So we're hoping to have a solution for all of those different suppliers and consumers. What we wanted to do was, first of all, to understand what's going on with SBOM, and in many ways, the NTIA has led that, and we intend to follow in their footsteps very closely. And I've been working with the NTIA now for almost 2 years. We want to align and emulate with their program, and as I said, shamelessly copy the healthcare POC as we sort of populate the industry with that knowledge, and hopefully lead those agencies and other industries. We want to make the case for SBOM in the auto industry, even though we are, I think, a very good industry in terms of cybersecurity and supply chain hygiene and technology generally. We are not yet fully convinced of the need for SBOM or the value of it. So we want to make sure that that is explicit. We want a unified voice from suppliers, which will really help, I think, when we go to the OEMs. They'll have a ready-made solution, and we'll be inclined to just adopt that rather than get fussy about it. Very practical approach with input from customers, partners, everybody up and down the chain. Perform the exercises, extremely important, as Jim and his team have done. The practical application is much more important than the theory. And We want to recommend and get agreement for the industry generally, and potentially, let standards organizations know and let them eventually follow our lead if that's appropriate. And then finally, we want to encourage and foster voluntary production adoption by suppliers. The POC we think will get great interest in, but we want to make sure that this is, this proliferates throughout the actual supply chain. All right, so what are we doing here? So first of all, I mentioned that we had a phase 1 where our primary objective was to influence the NTIA's findings and kind of steer that a little bit to make sure that the auto industry was represented. And I have been basically performing that duty now for the better part of 2 years. But now in phase 2, we have actually started in earnest to figure out what we want to do in the industry. First, we started with 3 one-hour tutorials by many of the folks from the NTIA. MSP stands for multi-stakeholder process, right? As Alan alluded earlier, the leaders and many of the doers that are in those programs, and that is completed. And we also, as a result of that, now have sort of the SBOM 101 curriculum in the form of their slides and materials for background. Then we intend to cycle through the sort of the PDCA cycle, the Deming cycle, and first do some planning, figure out what we want to do, who with, and what our executables are, do the actual execution, build the SBOMs and conduct the exercises, review what we learned, and then make adjustments and cycle through again. We think we'll need some small single-digit number of cycles to get this done, and the output from this will be supplier recommendations for the industry, meaning our customers, the OEMs, in around 12 months or so, somewhere in that ballpark. We haven't got the plan fully vetted yet. But that's generally it. We're very excited about it, and we're also very excited to sort of be leading the next industry program, and we're very interested in helping other industries get there, especially other industries that my company has an interest in. So
Thanks,
anyway,
Charlie.
that's it for me. Alan, turn it back over to you.
I really appreciate that. Thank you. And I want to briefly sum up. We've got a few questions in the chat, not many. So if you have something that you want to ask, now's the chance. But just very briefly, future of SBOM. Right. This is something that we're seeing interest in the U.S. and around the world. Companies, governments. Right. This is something that a lot of people realize we're going to need. We're starting to see it in standards and guidance, and we want to make sure is that this is something that actually scales, is usable, and is useful. Right? We don't want to do this just for its own sake. We've all come across examples where we sort of say, hey, here's your new requirement. It doesn't really help. So the vision here is to make sure it can help. And that we need a common set of practices and market expectations that are viable and that reflect the needs. So, right, sometimes we're going to see SBOM as public, other times very much not. That's going to be up to the community to decide and figure out what works for them. So here's a very quick summing up slide that we're going to need cross-sector solutions, and each community is going to understand their own implementation, but we need uniformity so that we can all build on similar approaches. And that's going to require industry leadership. And so those of you who are listening and say, hey, this is a good idea, and I think my organization can play an important role, is what we're really looking for now. So over the next few weeks, we're going to have some more detailed briefings focusing on the technical side, sort of, hey, more detailed in terms of when we define an SBOM, what exactly does that mean, and what are the existing standards? There are 3 existing data formats today, and the community has emphasized interoperability. And as you look at it, you can say, all right, we want to start with this one because it's the right fit for us. We want to have the initial set of conversations about what this can look like. We have this great lesson that the healthcare community has given us of sort of, hey, here are the suppliers, here are the customers, in this case, the asset owners for energy, and then here are some of the third-party support organizations that we all depend on to do this. As Tom mentioned, building out the ecosystem is going to be great. And then the final plea is, if you want to stay involved, please reach out. We're going to be building a mailing list. INL has generally offered to host that mailing list that will just be to sort of make announcement at this stage. So if you have not received an email from me and would like to, there's the email address. I'll put this in the chat. We have a few questions out there. One just on the data specifications, we're looking at SWID. There are 3 data specifications out there. There is SPDX, there is Cyclone DX, and there is SWID. You can find some information on those at ntia.gov/SBOM, and we're going to be having a whole info session looking at exactly those data standards with representatives from those. The other question I see is, hey, is this about source or binary? And really, at its core, this is about dependencies. And the attackers don't care whether you only have access to the source or access to the binary. What we need to do is sort of support both use cases. And in fact, we have a working group at the moment that's devoted to saying, here's the steps that you go through if what you have is source, here's the steps you go through if you have binary. And the community can really sort of decide. I think starting with one or the other is going to be very helpful. If there are any other questions, feel free to put in the chat. I want to briefly sort of give the last a quick last moment to see if Tom or Ginger or Jim have any last thing that they want to sort of say before we dive in here.
Yeah, I just wanted to point out that we're really going to have 3 groups in the proof of concept: suppliers, electric utilities or users in general, and then the other one is third parties and software developers, because there's SBOMs as they're produced by the suppliers aren't something that can be immediately picked up and used by the community. There needs to be some processing. In some cases, the utilities, the end users will be fine doing that on their own. In other cases, they won't. And so there is definitely a market for third parties providing the software, providing services as well as software to do that processing. So they will be part of the POC as well. Right. Thank you.
And Ellen, I'd like to offer that as there is interest and the community gathers down the road, the Citrix program and especially our sister lab, PNNL, who developed the framework for how we're leveraging SBOM, would love to present on our use and findings and lessons learned from employing SBOM so that can help the proof of concept team get an accelerated technical start.
Excellent. Thank you so much, everyone. We will be making this recording public. We will try to get the slides public as well, as I saw there's a request for that. And the vision, as I mentioned, is really we're now looking for folks who, some of you just want to stay involved and in the loop. That's great. If you think this is the sort of thing where you'd like to help pull this together, please reach out. We'd love to learn what your perspectives are, what your vision is, and how we can sort of pull together a consensus vision to move forward. In the meantime, pay attention to upcoming email lists. We're going to, as I mentioned, we're going to be building out an email list. If you've already received a reminder from me about this, then I will add you to the mailing list. And our approach is to say we're going to have some more info sessions to really dive into the technical side of things, because I noticed in the question, a lot of you are saying, this is all well good, but I'm an engineer. What do we build? And that's what we want to get to next. So thanks again to Tom and Ginger and Andy, Jim and Charlie, and thank you to my colleague Catherine for organizing this today. We are looking forward to working with you in the future, and we'll be having an identical webinar this afternoon. So you don't have to join, but feel free to tell your colleagues that they should listen in because it's good content. Have a great morning, everyone. Thank you so much for joining.